Welcome to this comprehensive video course on Pytest, the powerful testing framework for Python. Throughout this course, you'll gain a deep understanding of Pytest's features, best practices, and the nuances of writing effective tests. And at the end, you'll learn how to use ChatGPT to help you write tests quicker. Farhan Ali created this course. He is a freelance web developer who specializes in both design and full-stack web development.
What is going on, you guys, and welcome to this video brought to you both by Rhythmic and freeCodeCamp. Now in this video we're going to be covering testing in Python, and this is aimed mainly at beginners to introduce you to this world, but also for professionals as well who are also curious in using Pytest in their day-to-day lives. So first of all, what is Pytest? Now Pytest is of course a testing framework. It's in the name and also in the title of this video. But what comes out of the box? Well, first of all, one of the great features of Pytest is this thing called auto-discovery of tests. Now, what does that mean? Well, auto-discovery of tests, all that means is that Pytest has the ability to pick up tests based on the way we name them. So for example, we can name a test underscore and then the name of the file, or we can have it as the name of the file and then underscore test, and it will know that in this file there will be tests, and usually your IDE, so for example if you're using PyCharm, will also be able to detect this, and you'll be able to just click play and run your tests. The other naming convention is also when we have test underscore and then the name of the function, that will then imply to Pytest that this is a test, and you can also run those individually. Now, another great thing around auto-discovery of tests is that there's no explicit registration needed. So unlike some other frameworks where you might need to build a list or a registry of tests manually, Pytest automatically identifies which functions and methods are tests based on their names. And it also simplifies test execution. With auto-discovery, you don't need to specify each test case to run manually. You just run Pytest command and it will discover all the tests. And you'll see that later on. The next thing that comes with Pytest is rich assertion introspection, which sounds like a very fancy term, but all that means is that with a rich assertion introspection, that when a test fails in Pytest, we get a really nice breakdown as to why that test failed. So we get really nice clean reports that make it very easy for us, the coder or the developer, to understand, so we know exactly where our tests went wrong, or not even just tests, but what we're testing went wrong. And another great thing that comes with Pytest is this support for parameterized and fixture-based testing. Now, what that allows us to do is it basically means that we can easily run a test function multiple times with different arguments, ensuring that a broad test coverage with minimal code is that. So we could test that a certain number will show up depending on the value, and we can give it like a list of numbers and it will just run it for each one, so we don't have to write each test manually, which saves a lot of space and also provides us with it makes it very readable for the developer. Now we've explained what Pytest is. The next is, why do we need Pytest? Well, first of all, one of the great things with Pytest, or the reason why you should be using Pytest, is that it has a very simplified syntax. Pytest allows you to write code or write test cases using plain assert statements, which is the assert statement that comes with Python, without needing special assertion methods like assert equal or assert true, which you may find in other Python testing libraries such as unit test or nose. Another one is, of course, rich assertion introspection, as mentioned earlier, providing us with clear reports when our tests go wrong. It also has a very powerful fixture system. And what that means is Pytest's fixture system is both flexible and powerful, allowing for setup and teardown operations. So we can easily include operations to run before a test starts, and also write in teardown code, so when a test is finished, we can clean it up. We also have these scope, or these fixtures can also have scope and auto use settings, meaning we don't have to keep, let's say we're testing an object, we don't have to keep creating that object each time. We can have a place where the object is created and we can use it for all of our tests. This still might sound a bit confusing, but we'll see it in the code and you'll get a better understanding of how powerful this fixture system actually is. Another great feature of Pytest, or why you should use it, is compatibility, as Pytest can run tests for unit tests or nodes, so other Python testing libraries. So you can kind of easily migrate over to Pytest if you're using another one. And so it doesn't really get in the way if you want to try out a different testing library. Pytest will still work. And that's why I want to focus on Pytest for beginners, as once you understand the concepts of Pytest, you can easily translate them over to different projects where you use different testing libraries. And finally, another reason why you should use Pytest is the extensibility. Now, Pytest has a very rich plugin architecture with many third-party plugins available. So, for example, if you have a Django application and you want to start testing it, there is, of course, a Pytest Django plugin that you can use there as well, which is tailored towards Django, and you can just plug that in and get rolling with it. But otherwise, that's the reasons why you should be using Pytest. It's enough talk from me. I mean, it's one thing talking about the theory, but now we need to see it in action. So I've gone ahead and opened up a new project, a new Python project. I am using virtual environment in this example. However, you don't necessarily need to, as we're not building out a fully fledged project. We're just using Pytest, the library Pytest. So whether or not you want to use it, it's a matter of preference at this point. But I've opened it up in PyCharm. You can also use VS Code. However, I do recommend PyCharm for testing, especially testing. And you can also use the community version. I am here as well. And that's because the way tests are integrated into PyCharm, it's very easy to get up and running with it. However, we're also going to use a command line for this as well. So regardless if you're using VS Code to Notepad, it doesn't matter, it still work. So first of all, we have our empty project. We need to go ahead and make the necessary installations. So the first one I'm going to make, and the only one I'm going to make, is pip install and then Pytest. Hit enter. And in this one, we're using the version 7.4.2, which I guess is the latest version right now. It doesn't matter, I guess, if you're using a modern version of it. It shouldn't really matter because the principles of Pytest and the way you use Pytest doesn't necessarily change. So we have this version, Pytest 7.4.2. Now we need something to actually test because we don't have any code, so there's no point testing. So let's go ahead and create some functions. We'll create a new Python package. I'm just going to call this source, and within that I'm going to create a new file, and I'm going to call this my functions. And we're not going to add anything special here. First, we're just going to demonstrate how to write tests, how to write the most basic Pytest you can. So first of all, in my test, we're gonna have a function, and all that does is add two numbers. So this may be a throwback for a few of you folks, as I guess this tends to be the example a lot of books or people tend to use. So return number 1 plus number 2. All right, and let's just do one more. We'll say divide. Say number 1 and number 2. And return number 1 divided by number 2. So pretty standard stuff. But in this case, the reason why we have that here is because we want to test it. Now, the reason why I'm getting these lines is because I need to reformat. So you'll see me do that from time to time in the tutorial. That's just to stop the IDE from complaining. All right, so we have our source. Next, let's create a new directory inside of our main project. So at the root of it, and we'll call this tests, like so. Now, if you remember from what I was saying earlier in the presentation, that what Pytest does is it has a great ability to pick up or figure out where our tests are going to be located. So because we're calling this tests, you'll have an idea that tests are actually in here. And within that, and also it's good for us because we also know that tests are in here because it's labeled and named correctly. Let's go ahead and create a new file, and we'll say test underscore my underscore functions. All right, so what are we going to do here? So we're going to test our functions add and divide. So let's get started. We'll say import and then Pytest. And we'll say import source my functions as my underscore functions. All right, so let's test our first one. We'll say test underscore add. And if you see here on PyCharm, you may also get this, you probably will actually, this play button right next to it. That's because it's detected that this here is a test. So PyCharm already has this great integration of tests. So you don't really have to use a terminal, but you can pretty much click this button and then the test should run. But we're going to use the terminal in this example. So we'll say clear, and we can actually run this now. And you may have already guessed it that this test should pass. So we'll say Pytest and then tests and then test my functions. And there we go. We have one passed and at 100% because we only have a one test function, and that test function is actually not testing anything, but this passes because there's no complaints coming from a failed assertion. So let's go ahead and actually write something in there. So we'll say result equals my functions dot add, and we'll say 1 and 4. So now we have a result. So we know from our own intuition that this is going to be 5. So we'll go ahead and say assert results equals 5. So if this assertion fails, then this is going to break and our test will fail. However, if it passes, then we get a pass. Let's go ahead and test that. So Pytest and then test my function and enter, and there we go. We have 100% pass, no complaints. But what if we were to change this value and say 6? Let's run it again. Enter. And there we go. We get a fail. So it's telling us that our test add failed. And down here, it's saying that where it fails. So what line exactly? And it's saying that assert result equals 6 is failing because result is actually 5. And we're saying that we want it to be 6. So yeah, it's telling us what value that should be. We'll set that to 5. So if you're working on a real life application, you may be expecting a certain value, but you're not getting that value back. At least then you will know, okay, maybe something's wrong. So you may go back either to fix your tests or to fix the application itself. So there we go with our test add. But let's just quickly go over what this assert statement actually is. So in Python, the assert statement is a debugging aid that tests a condition as an aid to debugging. If the condition is true, the program continues executing as if nothing happened. So in our case, it continues and there's nothing to continue, so there's a pass. However, if the condition is false, an assertion error exception is raised, which interrupts the normal flow of the program. So if we go back here and we look at our error that we got, we get here that it's an assertion error. So every time an assertion fails, we get this assertion error. That's why we're getting that value. But that quickly addresses how assert works. So you can see here that if this is not basically rendering to be true, then it's going to break. Now let's go ahead and write our divide test function. So here we'll say, what should we call it? Let's just say divide. So test divide, and it's always good to make sure that you're naming your tests properly. So divide, in this case, is very basic. We're just testing that divide works. So result equals my functions dot divide, and we'll say 10 by 5. And for you geniuses out there, you should know that 10 divided by 5 is 2. So we'll say result equals 2. Let's go ahead and run that. So here, just clear this, and then Pytest, tests, and then tests my functions, enter. And now we have 2 little dots here at 100% rate. Awesome. So that covers our very basic Pytest examples where we're just throwing a simple assert to make sure the value that we get back from functions are the values that we expect. But what if we were to test this by saying number 1 divided by 0? Because we know you can't divide a number by 0. So what would happen there? Well, let's go and try it out. And actually, let's go ahead and try it out on a different function. So let's say test divide and divide spelled properly, divide by 0. All right, so here say result equals my functions dot divide, and then we'll say 10 and 0. And then we'll say assert, and let's right now just say assert true. So if we say assert true, then this will pass. But let's see what we get when we test divide by 0. So let's just go into, just expand this, and we'll say Pytest and test my functions, and we get a fail even though we have this assert true. So why is that the case? So here in our divide by 0 test here, so it fails here on this my functions dot divide, and that's because if we scroll down a little bit, we get this 0 division error. So division by 0 is the cause of this 0 division error. So what if we want to test that type? What if we want to say, okay, if I divide a number by 0, I'm expecting this 0 division error. So we can actually do that in Pytest, and it's very simple. What we can do is say something like the following. So above this, as we know it fails on the function call, we can say with Pytest dot raises, and then we can say 0 division error. All right, and we don't need this result, and we don't care about it anymore. We just want to call the function without storing it. Let's go ahead and try this out. So back in the terminal, let's go ahead, clear all that, and then Pytest, run it again, and there we go. We get 3 passes. Because what we're saying here is that we're expecting a division error when we call this function. So even though the function itself fails, or there's an error in the function, we can test to make sure that error is there. And that can be very important. Let's say you're building an accounting tool and you're dividing by 0, you want something there too. But just to kind of drive this point further, if we go back to our divide function, we can say if number 2 equals 0, then we can raise, and let's change it to a value error. Let's do that. Now, if we go back and we run this again, and if I just clear all that, run it, we get an error because we're testing for a 0 division error, but in actuality, we're getting a value error. So all we have to do here is just change this to value error. All right, so that's our tests pretty much summed up, or our very basic test summed up, excuse me. But we're only testing for numbers. What about strings? Like, how would that work? Well, it would work the exact same way. And so what we can do is we can use the add function, and we'll say test add strings. We'll say results equals my functions dot add, and we'll pass in I like, and we'll say burgers. Now we can say assert results equals I like burgers, because it will concatenate it. So if we run this now and we go into the terminal and we say Pytest, test my functions, we get an error, and that's good because you can see here that there we made a mistake where we need to add an extra space here. See there? Like I like burgers, one word, and then what we're expecting is I like burgers is 3 separate words. So let's run that again, and there we go. We get 4 passes, looking beautiful, and that is what you want to aim for as a developer. But that brings us to the end of the first part of this tutorial, which is looking at how to write very basic tests. And now let's go over and start looking at how we can write class-based tests, because right now all of these are function-based tests. So for our class-based tests, the first thing that we need to do is write some classes that we can actually test. So write some extra code, because right now all we have are 2 very basic functions, which we can throw into a class-based test. However, I want to kind of, spice it up a bit and add a bit more complex code. So inside source, I'm going to go ahead and create a new file, and I'm going to go ahead and call this shapes. So within shapes, what we're going to have is a class called shape, and we're just going to use this for inheritance. So shape, and this is going to have a function that we'll override called area, and we'll have another one, and that will calculate the perimeter of a shape. Let's go ahead and add that in. Now let's go ahead and create a class which is going to represent a circle. And I don't know what is wrong with my spelling. And this is going to inherit from shape the init. So init, this will take in a radius, and we'll say self.radius equals radius. Then let's do the area. And in order to calculate the area of a circle, if you remember back from elementary, is we need to do pi r squared. So math, or return math.pi multiplied by radius and squared. So double asterisk and a 2. And then for the perimeter, we'll say return 2 multiplied by math.pi and then by the radius. And it'd be a bit embarrassing for me to say that. I actually had to look this up quickly before, just to make sure I'm right, as yeah, sometimes I forget these basic things. But anyway, so now we have our class circle. Now let's go ahead and test it using class-based tests. So what we need to do is create a new file, and we'll call this test circle. And it's a good practice to just name your class or your test classes or test files based on what you're testing. So in this case, we're testing the circle. So everything related to the circle will be in this file. And here we'll say import Pytest, and we need to import source.shapes as shapes. All right, so to define a class-based test, we'll say class and then test and circle. And let's just put pass there now. And this should pick it up anytime soon. If it doesn't, let's go ahead and just add test1, and we'll just say assert true. And again, if you're using PyCharm, you should see these play buttons show up now. If you're not, if you're using VS Code, you may have an extension, or there may be an extension out there, which I'm sure there is, where you can have the exact same effect. But I'm more familiar with running or writing most of my Python code on PyCharm. But anyway, now let's go ahead, and if we just run this, if you remember from the last example with my functions, when we had a test that didn't do much, it would still run. In our case, it should pass anyway because we're asserting that it is true. So we'll say Pytest and then test and test circle. And there we go, it's working. Let's actually just jump into tests because we're going to be running everything through there. All right, so one of the cool things about tests or class-based tests is that it comes with two functions that can be quite useful. The first one is the setup method. Now the setup method is there, or is defined to run setup code before each test method. So for all the test classes or test functions or methods that we write inside our class-based test, the setup method will run at the beginning of each test. And then, like as a partner to it or to complement it, there is the teardown method. And the teardown method is there or defined to run teardown code after each test method. So after each one runs, there is a teardown method. So let's go ahead and just show that off. So we'll say setup underscore method, and we'll pass in this argument method. Now the method argument just represents the test method that we're about to run. So we can just say here print, and we'll have the setting up and then method. And then we'll have another one, and we'll say teardown underscore method, and throw a method in there. print and setting, or in this case, tearing down, and then the method. All right, so if we test this, let's go ahead and use the Pytest command and say test circle, hit enter. So we get a test passed, but if we look at what the report generated, we're not getting anything else. So we're not getting our print and we're not getting our tear down. And the reason why we're not doing that is because when we call or when we use the Pytest command in our terminal, we need to add a -s. So we can say Pytest and then -s. And now we get our print statement. So setting up and then the method name. So bound method, test circle, test1. And so it's just printing out the name of this test function that we have. And then it's called teardown. So if we did another test, let's just copy test1. And then here we'll say test2. And if we were to go back to the terminal, run it all again, now we have 4. So we have setting up, test1, tearing down, test1, setting up, test2, tearing down, test2. Now you're saying to me, okay, this is all well and good, but this is useless. I mean, we're just printing stuff out. Well, one thing that can be quite useful is that in the setup method, we can have something like, say, self.circle, and we'll say shapes.circle, give it a radius, say 10. Now, for every method that we have, a circle object is going to be created. So now we can access it in test1, and instead of calling it test1, let's say test radius. So test radius. And then here we can say cert and then self.circle radius equals, and we will need the math function. So let's just import math. And we know that the radius has to be math. And we need pi multiplied by self.circle.radius. And this here should be area. And we should name this part here to area. I don't know why I put it as radius, but area. And then this should be multiplied and then squared. Now let's go back, and inside the terminal, we'll say Pytest and then test circle. And there we go, we get our test. And you can of course add the -s as well. So like this. But that is how the setup method can be useful. Now in our teardown, we can also do something like delete self.circle. And in this case, it's not necessary because it will be doing that anyway. But for more complicated programs that you're testing, this teardown method can be quite useful along with the setup method. However, that's our class-based test sorted out. Let's just clean it. Let's just finish it off really. Let's add a new test and say test perimeter, because repetition with this helps. And then we'll say result equals self.circle.perimeter, and then expected value equals 2 times math.pi times by self.circle radius. And then we can say assert and result equals expected, again, spelling error, expect. Am I just going crazy here? Oh yeah, I thought it was a spelling error. We need to change that too. Sorry, long day. And there we go. So that's our test perimeter. Let's go ahead and test that out. And we're all green. Cool, so that's our class-based tests, like basically the overview of how class-based tests work, how you can set it up, and how you can use it with Pytest. The next cool thing I want to show you are Pytest fixtures. So I'm back inside of the shapes file, and what I want to do is go ahead and create another shape which we'll use to test. Well, first of all, we'll write our tests on, and we'll then use fixtures to improve on those tests. So down below, I'm going to go ahead and create a new class. This is going to represent a rectangle, inherit from shape, and we need to initialize it. This will take in a length and a width. Self.length equals length, and self.width equals width. Then let's calculate the area, return self.length by self.width, and perimeter, which we can do as return self.length multiplied by 2, and add that to self.width multiplied by 2. All right, so we have now our rectangle. Now we need to go ahead and test it. So let's create a new test file. Inside of the test directory, we'll call this test_rectangle. All right, so let's just go ahead and use our functional tests and write the very basic tests that we need. So we know we need to test. Actually, first, let's just make the import Pytest, import source.shapes as shapes, then test area, and here we'll say rectangle equals shapes dot rectangle, and we'll pass in 10 and 20. Then we'll say assert rectangle dot area equals and rectangle, or we'll say 10 multiplied by 20. All right. New line reformat. Okay, so we have our test area there. Now we can go ahead and run this just like we did before. So we'll say tests or Pytest and test rectangle, and we have one pass. All right, now let's go ahead and create another test, and we'll say test perimeter. And here again, we need a rectangle. So we'll take this here, paste it in, and say assert rectangle.perimeter equals, and that is 10 multiplied by 2 plus 20 multiplied by 2. Now, if we were to run this, go back here, clear, and test it again, we have 2 passes. All right, so nothing too special. You're like, okay, we've seen this before. What's so amazing about it? Well, one thing we can do, or one thing that you may have noticed, is that our rectangle is being used and declared twice. So we have 2 rectangles here, both with a length of 10 and a width of 20. The values there don't really matter, but the point is that we're repeating ourselves, that we're needing a rectangle in both cases, and we're creating a rectangle in both cases. Now, if we were to use our, test circle. So if we were to use class-based method, we could, or class-based test, we could of course have initialized it in the setup, but what about with functional? With functional, we can use something called Pytest fixtures. So we can do Pytest.fixture, and then say, we can call it my rectangle. You can name it whatever you want. And all this will do is return a rectangle. Like so. So now what we can do is we can literally plug this into each of our tests here. So we can say my rectangle here and my rectangle here. And we can remove this here, this rectangle equals, move it there as well, and replace rectangle with my rectangle or whatever you named it. So here and here. Go back up, go back to the terminal, let's clear that out, Pytest, and then test rectangle. And there we go, back to where we were, but now we are using our Pytest fixture. So just to kind of hone this in, let's create another fixture and let's use that as well as our my rectangle. So first of all, let's just go back into shapes, and I'm going to go ahead and create a new method, which, or not really create, but at least override the equals. And here I'm going to say if is instance. So if not is instance, what we want to do here is say that if it's not a rectangle, then we want to return false. Otherwise, then we're going to check to see whether a rectangle is equal to another. So we'll say other and then a rectangle and return false. And then here we'll say return self.width equals other.width and self.length equals other.length. So it's just a override for the equals, so we can compare two different rectangles. So now if we go back to test rectangle, let's create a new fixture and we'll say fixture, call this weird rectangle, name it whatever you want. I guess in a professional setting you'd want to name it something sensible, but here we'll say shapes dot rectangle and we'll say 5 and 6. All right, now we can use this weird rectangle, and down below we'll say test not equal, and we'll pass in my rectangle and a weird rectangle, and we'll assert that my rectangle does not equal weird rectangle. And we can go back to our terminal and just clear all that and say Pytest and test rectangle. And there we go, we have 3 passes. But the important part here is that we're using our fixtures. Now, one thing that is also important is that we can use something called conf-test. So we can make our fixtures global within our tests. So let's say, for example, you need the rectangle inside of test circle for some reason, and you don't want to keep on declaring more objects. So you want it in a global place so you can access it easily. Now to do that is fairly simple. All you need to do is inside of tests, we have to create a file, and we have to call this file conf test.py. And in here, this is where we can define our rectangles again. So I'm going to go here and I'm just going to take this. So my rectangle and weird rectangle, I'm going to save that and go into conf test, paste it in. Of course, we also need to import Pytest and shapes. So import Pytest and import source shapes as shapes. There we go. So now, if we go back to test rectangle, you can see that it's not complaining. We can get rid of this and let's go ahead and run rectangle again. So we'll say Pytest and test rectangle. And there we go. We have 3 clear tests, and we have our my rectangle in use and our weird rectangle in use, which we stored in a global place, which is our conf test. We can also access in other files as well. So inside, let's say our test circle, we can do, let's just come up with a silly example. So test not same area rectangle. And here we can pass in my rectangle, like so, and we'll say circle equals self.circle. Oh, we already have the circle because we defined it up here. So we can say assert does not equal, or self.circle dot area does not equal, and then my rectangle dot area. All right, now if we were to go into our terminal, once again, let's just clear all that and say Pytest and test underscore circle. There we go, everything's green, and we're making use of our rectangle that we defined in conf-test accessible, or we're using it in our test circle file. So this can be pretty useful, especially if you've got like a really large code base where you have a lot of shared objects. Then the conf-test can of course be very helpful there. So of course I wouldn't overabuse it, like I wouldn't store everything in conf-test, but this is just an example of how you can. Now the next thing that we're going to look at is something called Pytest marking and parameterizing. So the Pytest mark mechanism provides a way to add metadata to your tests. So you can think of it as tagging your tests with labels that can influence how the test runs or is reported. And the purpose of it is that you can label or tag your tests to categorize them. For instance, you might want to label some tests as being slow or some tests as to skip. And yeah, which means that you can conditionally execute your tests. So let's go ahead and do that. So back in my functions, we're just going to use add and divide as our examples because the purpose of mark is just to demonstrate how they work, not so much writing the tests themselves. So let's go ahead, and if I'm in my tests, we need my functions, we need to go to test my functions. So in here, let's go ahead and let's look at the slow tag. So let's just import time at the top of this. Say import time, go back down, and we'll say test very slow. And we'll have, let's take this here, result. Actually, let's just take all of this, paste that in here. And then above that, what we'll do is just do time.sleep and we'll say 10 seconds. So actually 10 seconds might be a bit too long for this video, so let's do 5. So if we run this, if we go into the terminal and say, just clear that, Pytest, and then test my functions, and it's still running because it's waiting for the last one, and there we go, it took 5 seconds. However, this is a slow test, and it didn't do anything, it didn't alter the way our tests work, so everything passed, and it managed to get to the end of this. But it can be helpful for us to know that this test is going to be a slow one. So we can say something like that. So that's just telling us, is adding some metadata to state that this is a slow test. So if we want to see the slow test or test the slow test, we can say Pytest and then -m and then slow, and it will only run the test my functions one because that's the only one that has a mark of slow. And we're getting a warning, mark slow. Is this a typo? I guess in this case, no. But anyway, it passed anyway. This is just a warning, it wasn't a failure. And let's go back. So that's the slow one. Can be quite useful. Let's say if you're, I don't know, if you're calculating something that takes a while to calculate, you might want to add that in. The next one is the skip test. So let's go ahead and say at Pytest mark and then skip, and we can add a reason to it as well, just for ourselves. Can be quite useful. And here we'll say this feature is currently broken, and here we'll say test add, and let's just assume that add is broken in this case. We'll go ahead and assert that my functions dot add 1 and 2 equals 3, and give that some extra room. Now if we go to our terminal, clear all this, and we run it again, so we'll say Pytest test my functions, enter. You can see here that there's one that has an S there as well. That means skip. So we're skipping one test. The other one is a slow one, but here we are. Like, that's a way to skip your test. So you just add that in there. Another one is the X fail. So we can go here and say Pytest and then mark and then X fail. And we can add a reason to this as well. We can say, we know we cannot divide by 0. And we'll go ahead and do exactly that. So test divide 0, say broken. Let's assume divided by 0 is a broken function. All right, so let's go ahead and say assert. Well, let's just make the call because we know it fails. So we'll say my functions divide 3, 4, and 0. Let's go ahead and run this now. So clear that, and then Pytest test my functions. Give that a second. And there we go. So if you go back here, we have the S that represents our skipped one. Then we have these green dots, which represent our passed. And then we have this X, which means that we know this is going to fail. And you can see here this breakdown: 4 passed, 1 skipped, 1 failed, 1 X failed. So it didn't fail in the literal sense that the tests themselves fail. It failed given that we marked it as something that can fail as well. So this is how marking can work. And it can be, again, quite beneficial to just add some extra information around your tests. There may be some tests that you know will break and you don't want to fix those tests, or there's certain reasons why you don't want to fix them. You can, of course, use this X fail. Then there is the skip, which just means that, yeah, you want to skip this test and maybe you'll come back to it later on. But you want the test in there just as a reminder. And then it'll also be useful for other engineers that you're working with, so they know, oh wait, why is this skipped? There's probably a reason for it, and they'll know the reason. So the Pytest mark can be a very useful feature, mainly for us as engineers, and also for your testing as well, depending on how you want to see it. But anyway, that's covered, that covers Pytest marking. Now we'll look at Parametrize. So for the example with parameterizing, what we're going to do first is back inside our shape. So we're going to add our last shape, and that's going to be a square. So we can actually inherit from our rectangle. And the way we can do that is by saying class and then square, inherit from rectangle. And here we'll say init, and we'll just give it a side length. And then here we can say super, and we'll pass in the side length for the initializer and side length for the width and the length. All right, so that's our square sorted out. So let's go ahead and create a new file inside of tests, and we'll call this one test square. All right, so for this, let's go ahead and make the necessary imports. So Pytest and import source dot my functions, actually shapes, as shapes. All right, so what is this whole thing around parameterizing? So imagine you have a light bulb and you want to test it with different brands of batteries to ensure that it works with all of them. So instead of writing each separate test for each battery, it would be more efficient to actually just write one test and run it for each battery brand. Now, of course, you could try this out with a for loop. However, for loops can get a bit messy and it just kind of ruins readability after a while. So instead, what the team behind Pytest have done is created this parameterize concept. So the way we can use it is, let's say we want to calculate the area of a square, but we want to give it multiple values. So let's just first define it. So test multiple square areas, and it'll take in a side length, and we'll define that in a second as a parameter and a expected area. And the way this will work is what we'll say is assert and then shapes dot shape and pass in the side length dot area equals the expected area. Now you're wondering, okay, where are these values coming from? They're not coming from the conf test because we haven't defined it there. Well, the way we can do that is here we can say at Pytest dot mark again, but this time parameterized. And here we'll define the first parameter, which is side length, and then comma, and then expected area. And then we need to give values for both side length and the expected area. So to do that, we'll say it's going to be a list. The first value of this tuple, so we'll have a list of tuples, and inside the first tuple, the first element is going to refer to the side length, and then the second one is going to refer to the expected area. And let's create a few of them, because right now that's just one, and then we'll do 4 and 16, and we'll do, say, 9 and 81. Let me just format this to stop it from complaining. All right, so what do we have? So we have this parameterized mark that we've placed on top of this test multiple square areas. Then we have side length and expected area. Now side length refers to the first element of each of the tuples that are in this list. So 5, 4, and 9. The expected area, however, is referring to the second element of each of these, the second element of each tuple. So 25, 16, and 81. Now we can actually just go ahead and run this. So let's go ahead and clear this out. And we'll say Pytest and then test square. And we get an error because shape takes no, this is meant to be square. It's a good job that we're testing to see this error. And then run it again. And there we go. And you can see here that we get 3 dots. And that's because we have 3 different tuples inside of our list. Now you can of course create another one. So we say random here. And if you want to use that, you have to add another value to this as well. Like so. So that's how parameterizing works. Now let's go ahead and do a bit of practice. Let's use it again on the perimeter. So we'll say here, we'll first add our decorator, mark, and then parameterize. And for the perimeter, we'll have a side length and comma, and we'll call this one expected perimeter. And then what we can say in this is the tuple is going to be first one, let's say 3, and the perimeter for that is going to be 12. Then we'll have another one, say 4, and the perimeter of that is going to be 16. And then we'll say, do another final one, be 5, and the perimeter of that is 20. And then we'll say define test multiple perimeters, and then we'll say the side length and expected perimeter. And we'll do the exact same thing. So assert and then shapes dot shape and throw in side length dot area equals the expected perimeter. And this should not be area. This instead should be the perimeter. And there we go. Let's go back into our terminal. And if we were to run this now, we get a bunch of errors because we have failed test multiple square areas in Parametrize, the number of names expected. It's this one here. We need to get rid of this random. Run that again. Shape again, so another one. So this has to be square. Don't know why I missed that. but this should be square. Go again. And there we go. Now we have 6 tests, but we've only, by looking at it at face value, just written 2 tests. So Parametrize can be very useful if you want to try the same test with different values to see what output you get, rather than writing like a for loop where it gets all messy. So yeah, definitely use Parametrize when you need to. It can be very powerful and very useful for developers who are reading it later on. So again, yeah, this covers the parameterizing with Pytest. Now let's move on to the next topic. So for the next topic, we're going to look at something a bit more advanced, and that's called mocking. Now, mocking is a powerful testing technique which is used to isolate the system that we're testing and replace the external dependencies with controlled implementations called mocks. So when might you use mocking? Now, imagine you're writing code that fetches data from an external API using, let's say, the request library. And when writing this test, you don't want to actually call the API itself because it might be slow, it might cost money, or affect rate limits. And depending on the API's actual data, as that is subject to change, it might cause your test to fail. So we don't want to depend on the API itself. Let's say we just know what the API is going to respond and we want to test that. The same may also go for testing a database. So you might have a test that is testing, let's say, getting a user from a database, and you don't want to depend on the database itself, as the connection might be disrupted and therefore your test might fail. So that's where mocking can come into play. Now I'm talking a lot, so let's go ahead and actually code an example up and see how useful mocking can be. So first, in the source directory, I'm going to go ahead and create a new file. I'm just going to call this service. And within that, what we'll do is create a dummy database where we'll get a user. So we'll say our database equals, and in there we'll say 1, that will represent the ID. We'll have Alice in there. 2, we'll have Bob in there. And 3, let's say we'll have Charlie in there. All right, now what we'll do is create a function which will get user from DB, and it will take in a user ID, and it will return our database.get user ID. So pretty much working a bit like if you're using an ORM, it might be similar. But in this case, we're just mocking it with a database. Or actually, we're not mocking it in the sense of testing. Let's just say this is actually our database. And we'll mock it in a second. Let me just format this. And then let's create a new file inside of tests. And we'll call this one test service. And enter. All right, so how do we actually mock this? So first of all, let's make the necessary imports. Let's import Pytest. We need to import source.service. Let's say service, and let's leave it at that. So there is another import that we'll need, and actually let's just do that now. So let's go ahead and say import right there, import and unit test, and then mock as a mock. All right, so remember right at the beginning of this video, we were talking about how you can use other testing libraries within Pytest without any issues. So we're doing that exactly here. And the reason why you don't need to install this is because unit test comes with Python. I think from 3.3, version 3.3 and onwards, you'll have unit test with every Python installation that you make. So you don't have to make an installation here. And mock is inside of there, and we'll use that for this. All right, so let's go ahead and create our test. So test get user from DB, and let's just put pass there. The first thing that we need to do is add a decorator to it, and that will come from mock, and we'll say patch, And then we need the route or the path to our, basically the path to our function. So we'll say source.service.get user from DB. And so that's going into our source and then our service file and then our function, which we called getUser from DB. Then we need to map that to an argument here. So a bit like how we did with fixtures. So what we'll say, or with parameterizing, or parameterize as we looked at earlier, we can say mock get user from DB. And this doesn't have to match this. So this mock part, the naming convention, there's nothing strict here. I've just named it that for readability, but you can call this whatever you want, so it doesn't matter. Then we'll say mock and then get user from DB, and we'll say that the return value is going to be mocked Alice. And then we'll say username equals, and we'll say service dot get user from DB. We'll put in the ID 1, and then we can say assert, and then username equals mocked Alice. So let's just quickly go over what we've just done once again. Now we're using the patch function from mock to replace get user from DB. So we're saying use this function that we've defined in our source service and replace that with mock get user from DB. And then here we're saying that the return value from this function call, so whenever we call it in this test, so in this test get user from DB, we want the result to be mocked Alice. And then here, that's where we're fetching from our database. That's when we're actually making use of our get user from DB. We call it, we pass it an ID, and then we're saying assert username equals mocked Alice, because we know as engineers, so in a real life setting, you will know that when you call this, it will return a string. And so if anything changes, you will have to adapt this test, of course, but that's how this is working here. All right, so that sums up the database test. Let's actually go ahead and run it. So let's go into terminal and we'll say Pytest and then test service, enter, and we get a pass. So there we go. Now, if we were just to replace this with say that, and then we run this, or maybe if I use a terminal instead, so Pytest, we're getting an error because a mocked Alice, the return value that we're getting from this, so get user from DB, does not equal ASDF. So there you go. So in this case, we're not testing whether or not the database works or not. We're just testing to make sure that the response we're getting is what we expect, is what we would expect. So that's where mocking can be quite useful. But this is a very simple example of mocking. Let's actually use it with an API. So the first thing that we need to do is back inside the root of our project, let's pip install requests. So we need this request library. I've just installed it with pip install requests just here. Now back inside service, we're going to go ahead and make an API call with that. So we'll say import requests. And what we're going to do is make a call to this website called JSON placeholder. And you can go to jsonplaceholder.typeicode.com. And here it just gives like free fake API for testing and prototyping, which can be quite useful for our case, for example. And we're going to use the users endpoint. So this one here. You can use whatever endpoint you want. I'm just going to go with the users. So when we fetch or when we do a get request, we're going to get this here. So back in our code, let's go ahead and create a function which will get the users. So down here, we'll say get users. Then here we'll say response equals, and we've imported it, yep, requests dot get, and we need to paste in the URL. So this URL here, copy that, paste it in with double quotes, and then if the response.status code equals 200, meaning that the request was successful, we'll return response.json. And then here we'll say raise requests.http error. So if there is an issue, if it's not 200, then we want to raise a HTTP error. All right, now let's test this. So like I said, when we started talking about our mocking, is that you will use mocking for something like testing or fetching from an API, but you don't want to test the API itself. That API is someone else's responsibility. We're just testing, in our case, that we get the response that we want, or we're getting the expected data that we want. So remember, actually calling an API in a test might not be the most economical thing to do. It might actually not be the most efficient thing to do as well, because APIs can be slow. So let's go ahead and use or test our function. So the first thing that we need to do is, of course, map it with the patch. So we'll say this mock.patch, and we want to mock the request.get. I'll explain it further in a second. So requests, so make sure it's s.get, and then we'll say test underscore get users and mock underscore get, and then we'll say pass. So let's just quickly explain this. So we're testing our get users, but we don't want to test necessarily the function, or we do want to test the function, but we want to mock the request.get. So whenever we call request.get within this, which we will because we'll be testing the function, then we want to get a certain response. So let's go ahead and say mock underscore response equals mock.mock, like that. And then we'll say mock response dot status code. And don't worry if you're confused, because I found this very confusing when I first learned it. And then mock underscore response dot JSON, and then return value equals, and we know that the data looks like this, but because we already know that, we can shorten it. So we'll say something like ID. Usually you would use like an exact example of it, but for the purpose of this, it doesn't matter because we already have an idea. Name, and then John Doe, and then mock underscore get dot return value equals mock response, and then data equals API or service dot get users. And then we'll say assert data equals ID 1 and name John Doe. Okay, so to explain it, what we're doing here is so let's start from line 18. So we're calling this get users, and within get users, we're using request.get. And in our test, this is what we're mocking. So we're saying whenever this is going to be called within our test, we want it to come back with a response. And the response that we want is in the form of this. So this JSON return value ID 1 name John Doe. Because in our service, response has this JSON that we're returning. So if the status code is 200, then where response JSON is going to be returned. And we want to say when this is returned and it's successful, then it's going to look like this dictionary here. And then we also want the status code, so we're setting that to 200. And the reason why we're not just saying mock response.json equals dictionary is because the difference between status code and JSON with our request.get response is that status code is actually a property and JSON is actually a function or a method call. So that's why we have to add this dot return value. So let's go ahead and test this now. So clear, and then Pytest, test. We're outside, so tests and then test service, enter, and we have 2 successes. That means our data is the value that we're mocking to JSON.return value. And we can also say that, or in our case, it doesn't really matter. We can't test this because our service is returning the response.json anyway. But to drive this a mocking point further, if we go back to our service, we can see that if the status code is not a 200, then we should get a HTTP error raised. So we can go ahead and use our mocking power to make sure that that is the case. So we'll say mock.patch and then requests.get. And we'll do here test get users error, and then mock_get. And within here, what we'll do is say mock response. So we'll take these 2 and paste that in and set the status code to 400. And then we'll say mock_get dot return value equals a mock response. And then we'll say with Pytest dot raises requests dot HTTP error and API or service dot get users. It should now work. So let's go ahead and run it. And once we run it, we get a pass because we're saying that the status code is a 400. So with that in mind, we should get a HTTP error. Now, if we were to change that to a 200 and run it, we get an error because it did not raise, even though we have a 200. We were expecting a raise, but instead we got a test fail. So that should give you a good idea, or hopefully gives you a good idea as to how mocking works with Python testing. Now, it might be a bit of a tricky thing to grasp at first. It is a bit of a weird concept. It was definitely for me. However, one rule of thumb that I would apply is when you want to use mocking, or if you're kind of in a bit of a dilemma, if you want to use mocking or not, I tend to use it when my tests are dependent on external programs that can give or cannot guarantee the same result each time. For example, if you're testing an API, you cannot always guarantee that if you give it certain inputs, you will get the exact same output each time because, you know, an API can of course crash. It may have some downtime or whatever, or may take some time to actually give a response depending on the day or situation. So you can't really guarantee that. And your tests need to guarantee that you always have this result when you make a certain call to a function or a program. So keep that one in mind and definitely play around with mocks as they can be very powerful when used correctly. Now let's move on to our final topic where we'll look at how we can use artificial intelligence to help us write our tests. So in order to test AI when it comes to writing our tests, to see how well it can write Python tests, head over to openai.com and there you'll have access to ChatGPT by clicking on try ChatGPT. Now, I already have an account. I have a pro account, which costs around, I think, $20 a month, and it's definitely well worth it, especially if you're a developer, as the value that you get out of it is substantial. But we'll also try it out on the free version, so the 3.5 version, and on the more up-to-date version, ChatGPT 4. So I've already signed in, and this is my account. So this is my prompt. I can click on either ChatGPT 3.5 or GPT-4. With the 3.5 model, this is available on the free version. So if you're not paying for it, you will have access to this. And let's go ahead and see how useful this will be when it comes to writing our tests. But before we do any of that, what we need to do is go ahead and write some more code. So in our source, I'm just going to go ahead and close all of this. And what we'll do is create a new program or a new class inside of this. We'll call this school.py. And now this will represent, or this will hold a classroom, and that classroom will have a teacher and a number of students. So let's write it up. Let's go ahead and say classroom, and say init. You can initialize it with a teacher and students, and say course title. And then we'll say self.teacher, so all the standard stuff for initializing a class, self.students equals students, and self.course title equals course title. All right, then we'll have a function where we can add a student, and we'll pass in a student to this, and we'll say if the length, maybe we don't need the parentheses, so if length of self.students is less than or equal to, say, 10, then we will add a student. So students.append and student. Otherwise, we want to raise an exception. Let's create our own exception over here. We'll say class too many students, so inherit from exception. We'll say pass just here. Now back down here, we will say otherwise raise too many students. Then we'll do remove student, so remove student. This will take in a name, and we'll say for student in self.students, then if student name is equal to name, then self.students.remove, and then student. And then finally we'll break. And the last one we'll add is a change teacher. And we'll say new teacher. Say self.teacher equals teacher, or new teacher. All right, so that's our classroom. The next thing that we'll add is a class that will just represent a person. So it's nothing too fancy. Person. And this will take in a name, and self.name equals name, and then class teacher will inherit from person, say pass, and the same goes for the student. So student inherit from person, and we'll say pass as well. All right, so just to quickly run through what we have an exception, too many students, which we use in the remove student, so, or in the add student. So if there are too many students, if there are more than 10 students, then or if it's the number of students is 10 or more or less, then we'll add a student. If it's more, then we'll raise the exception. Then we have our initializer, where we set our teacher, our students, and course title, and we can also remove a student as well as change the teacher. Then we have our person class, and then that just takes in a name, and our teacher and student inherits from that. All right, so let's see what our AI makes of this. So I'm just going to copy all of that. And what I'm going to do is I'm just going to close this, and then back in here, we'll say using Pytest and the functions that come from it, such as fixtures, parameterize, spelled correctly, I hope, raises, and mark wherever necessary. Test the following code and theme it after Harry Potter, because after all, we are using the classroom teacher student. So why not make it a bit more creative? And colon, and then paste in the code, enter, see what we get. So using Pytest and the functions that come with it, such as fixtures, parameterize, raises, and mark, wherever necessary, test the following code and theme it after Harry Potter. Maybe that could be worded a bit better, but anyway. So to test the given code and theme it after Harry Potter, you can use Pytest along with fixtures, parameterize, raises, and marks. Here's how you can write tests for the classroom. So let's see. We have a fixture defined for us, which is Harry Potter. And it's setting Harry Potter as a teacher. I don't know how to feel about that one. Maybe, yeah, that's weird because then Hermione Granger is a student and Ron Weasley is a student as well. Anyway, maybe Harry Potter is doing well in class. He's now been leveled up to being a teacher. And then we have the Hogwarts classroom as a fixture. It has an empty list of students. The teacher is Harry Potter. Then we have our students, and the class is Defense Against the Dark Arts. So far it's theming all right. I think the only thing it got a bit wrong is Harry Potter being a teacher, but anyway. Then test the cases for the classroom class. So test classroom creation and teacher name Harry Potter, this, and then, so what is this doing? Test cases of the classroom class. Oh, okay, it's just making sure that the fixture that we have is properly defined. Then test add student. We're adding Hermione Granger to the class and Ron Weasley, and the length of it is now 2 because originally we had 0. Okay, that works. Test add too many students. So now we're adding 10 students to this. And then finally, and that's just like random students, so generic students set to the name student. With Pytest raises too many students, maybe, I mean, it is 10 students, so I think parameterize would have been a bit too much here, but the for loop makes sense. Then we're adding Hermione Granger, and it should raise too many students because that is more than 10. Then test remove students, so we're adding Hermione and Ron. Then we're saying remove Hermione Granger. The length of it should be 1 now, and the name of the first student should be Ron Weasley. Then test change teacher. We're changing the teacher to Severus Snape. And if you're a big Harry Potter fan like me, you'll know Severus Snape always wanted to teach Defense Against the Dark Arts. So I guess his dream has been fulfilled in this test. And then we're setting the name to Severus Snape. All right, it looks pretty good. So let's go ahead and copy that, and back in our code base, let's create a new file in tests. We'll say test_school. And here, let's just paste all of it in. And let's just correct our import. So we need source.school, and let's go ahead and run this. So I'm just gonna increase this, clear it, keeps doing that, let's clear it again. All right, let's run this test. So Pytest, and then tests, and test school, run. And we get an error because this did not raise too many students. Let's see, let's go back and ask it. So we'll say this, let's copy this. This test is failing. See what we get. I apologize for the oversight, no worries. All right, change this. All right, it's telling us to change the code that we're testing itself. So maybe, okay, the issue is this equal less than and equals to. So let's go back, and yeah, maybe that's correct. So if the length of students is less than 10, now let's run this. Then we get all passes. All right, so maybe you kind of have to shake ChatGPT up a bit, but this is us changing the code itself, which I'm not a huge fan of. So if we set that to equal to, if the length of the students is equal to 10, then add a student. And maybe actually this is actually our own error because we want only 10 students. And so yeah, I guess it kind of made us rethink that a bit, but it's been quite useful. So that's the free version. That's ChatGPT 3.5. Let's go ahead and try it out on ChatGPT 4. So I've gone ahead and selected ChatGPT 4. I'm using the default one, and this is the version that comes with the paid one. So it's only exclusive Plus users. I definitely recommend it. It's definitely worth the $20 if you have it, as the value that you get out of it is just fantastic. So I'm going to go ahead and paste in the exact same query. So using Pytest and the functions that come from it, such as fixtures, parametrize, raises, and mark, wherever necessary, test the following code and theme it after Harry Potter. Let's see what we get. All right, so far it's somewhat similar. So we've got the students, and this fixture is returning a list of students. So Hermione, Harry, Ron, Draco Malfoy, Luna Lovegood, Neville Longbottom. Wow, so it's really added like a whole load of students to this. So it's really understood Harry Potter, I guess. And then the class is Transfiguration class, and it's setting McGonagall as that. And if I remember correctly, McGonagall is the teacher for Transfiguration. And this is a fixture for that. Add student. So adding Ginny Weasley, add student, and assert new student is in the list of students. Okay, very nice. And then we have the too many students, Transfiguration class, new student Dean Thomas, and raises too many students, Transfiguration class, add new student, and then Pravati Patel, and then test remove student, and it's using Parametrize here. So student name Ron Weasley and Draco Malfoy. That's pretty cool. And then test change teacher, so it's changing Alistair Moody to that. Okay, let's actually go ahead and copy this, and let's actually just count how many tests do we have. We have 1, 2, 3, 4, and 5 if you count the other parameterize. So let's say 4. In our test school, we have 1, 2, 3, 4, 5 tests. Okay, it's not a huge difference. Let's go ahead and take all of this, delete it, and paste in our new one. We just need to correct this. So we'll say source.school. Let's go ahead and run that. Let's clear this and run it. And we get an error. And that is because it's still, we never changed our students, or like when we gave it the prompt, we never gave it the updated one. So what we'll do is let's just quickly fix that, and we'll give AI the benefit of the doubt. So maybe we get rid of a student. Let's get rid of Seamus Finnegan. No hate, just that he was at the end of the list. So let's run that again. And there we go. We have 5 passes. So in all honesty, I would say that the ChatGPT 4 one performed only slightly better, only because we have this parameterize that comes with it. And the naming is a bit better as well, like it's stayed in line with the theme, but that doesn't really matter in terms of tests, just to like spice it up creatively. But that brings us into this tutorial. We've now seen how AI can also be useful when it comes to writing tests. I definitely recommend it, as it allows you to kind of catch the areas that you tend to miss when writing tests. So definitely make use of it. But otherwise, subscribe to freeCodeCamp. You can also contact me, which is my channel is in the description along with my Twitter. But otherwise, stay healthy, stay safe, and see you soon.